Assalamu alaikum, madam. The name of my topic is exhaustive search. My name is Mohammed Sadiq Pial and my ID is B180305053. I'm presenting exhaustive search. So, at a glance, first of all, we'll see the topic. In our topic, we have first of all we have the introduction, and then we'll see an example, and then we have the pseudocode, and we will see the implementation in the NetBeans with IDE, and we will see the complexity with worst case and best case, and at the end I will show what will be the reference. So first of all, let's have the introduction. Exhaustive search, or mostly called as brute force algorithm, it is also known as the generate and test. And brute force or exhaustive search is a general problem solving technique and algorithm paradigm that consists of systematically evaluating all possible candidates for the solution and checking whether and each candidate satisfied the problem statement. Then last, the aim of the brute force algorithm. The aim of the brute force algorithm is to construct an algorithm that's capable of finding a pattern in a given text. So shortly we can say that exhaustive search, by using exhaustive search, we can get, or we can uh, find a pattern in a given text. Let's understand with an example. So we have a given text, which is is a test, and we have the pattern called test. So we will find this pattern test from the given text. This is a test with the brute force algorithm. In brute force algorithm, we have to find a given text in a given text, given pattern in a given text. We have to keep iterating through that text, and if there is a mismatch, then pattern will be shifted to the next step to the right. So here is the total table. So here we can see this is our test, and first of all we will match the first character with the given pattern. So here we can see that uh, the first character already matched, but then we will shift to the next character. Then you can see that this is not matched, then we will shift to the right. And here if we match the character with the text character, then we can see it's mismatched. Then we'll go to the next step, we'll shift it to the right. Then we can see that we are matching the first character with the next character. Then we will see, you can see that it also mismatched. Then we'll shift it to the right, and so on. We'll will match the pattern with every single character. Then we can see that it's mismatched, and it is also mismatched. And then at the end we can see in the last text, J, we can find we match the first character with the pattern character. Then first character is matched, then we check the second character, then it is also matched. And we will match the third character, and it is also matched. And at the end, the end character also matched. Then the pattern is matched with the given text. So the main aim of this brute force algorithm is to check to match the given pattern with the given text. So there is the pseudocode. So the pseudocode is do if text equal to pattern, then compare it to the next letter of the pattern to next letter of the text. Else move the pattern down text by one letter. If the pattern letter is matched with the text letter, then we will compare the next letter to the of the pattern to the next character of the text. And if it is not matched, then we will move the pattern right to the next character. So it is the implementation with the in IDE. So first of all, we will take the text length and pattern length. Then first we will take a loop to find the length and the pattern length of the text, and then will give us, and under this loop we will give us another loop to find the text character. So if the character if the text character is not equal to the pattern character, then we will give a break to we will give a break to shift it to the next next pattern. And if it will if the text character is equal to the pattern, then we will check the next character, and we will return the index. And here we will take the text, we will scan the text and scan the pattern. And then if the pattern is matched, then we is not matched, then we will print the code will print that pattern is not found in the text. And if it is matched, then pattern is found at position, it will this will print. And the worst case of this algorithm is we have to we have to check every step. If the pattern contain m number of characters, then we have to check individually every character, and this comparison will be done m minus n in the character in the text. Thus the running time obtained is n minus m into m plus n. And the best case will be if there will be if the pattern is not found, that is always mismatched in the first character, then it will be the best case, because it will not take any next action, because there is no matching in the text. So my reference is YouTube, and I take help from my textbook and class teacher, and plus also video, and etc and etc. Thank you, ma'am. This Thank you, Linda Islam and Sonia Korea, ma'am, for giving chance to give the presentation.
Assalamu alaikum. I am Tamanna Rahman Tunni. My presentation topic is about fractional knapsack. First, here is my content. Their introduction to greedy algorithm, history of knapsack problem, introduction to fractional knapsack, solution of fractional knapsack problem, algorithm, code implementation, sample input and output, complexity analysis, application, and references. Here is my introduction to a greedy algorithm. A greedy algorithm for an optimization problem always makes the choice that looks best at the moment and adds it to the correct sub-solution. Final output is optimal solution. Greedy algorithms don't always yield optimal solution, but when they do, they are usually the simplest and most efficient algorithms available. Actually, greedy algorithms we use for take a optimal answer to maximize our needs. The history of knapsack problem. The name knapsack problem dates back to the early works of the mathematician Tobias Danzig and refers to the commonplace problem of packing the most valuable or useful items without overloading the luggage. Here is the fractional problem introduction. The fractional problem is an algorithmic problem in combinatorial optimization in which the goal is to fulfill a container with fractional amounts of different materials chosen to maximize the value of the selected materials. Here gives a set of items each with a weight and value. Determine a subset of items to include a collection so that the total weight is less or equal to a given limit and the total value is as large as possible. Here is a solution of knapsack problem. First of all, we can see a problem of knapsack. I use three objects with their profit and weight, and the capacity of knapsack is 20. So we use three ways to get our optimal answer. The ways are: way 1. Here we are greedy about our profit. Here we take first the object whose profit is greater than others. So there is a chance to get highest profit and continue this process until the capacity is filled up. At last we add the profit of the objects according to the capacity. So first of all we choose object 1 and get profit 25 and its weight is 18, but our capacity of our knapsack is 20, so the rest of the capacity is 2, and the second highest profit is 24 and it's for object 2. Its weight is 15, but we have the rest capacity 2, so we use the fractional part of object 2. So here's my calculation: 25 the profit of object 1 and the fractional part of object 2. The result of profit of maximum profit is 28.2 for greedy about profit. Way 2. Here we are greedy about our weight. Here we take first the object's profit whose weight is much lower than others. As a result, we can take more object until the capacity is filled up. And at last we add the profit of objects according to capacity. So we take first object 3 as its weight is lower than others and it is 10. Its profit is 15. After that, the rest of the capacity is 10. Next, we take object 2 as the second lowest weighted object and it is 15. The profit of object 2 is 24, but we have the capacity of 10. So here's the calculation is 15, the profit of object 3 and the fractional part of object 2. So here's the answer is 31. And the last way is greedy about both profit and weight. Here, first of all, we calculate the proportion of profit divided by weight for each object. Then we choose that object whose proportion value is greater than others. So here we take object 2 firstly and its profit is 24 and weight is 15 and the rest of the capacity is 5. After that, we choose object 3 as its ratio is greater than object 1. Its weight is 10, but we have the rest capacity 5. So we have to use the fractional part of object 3. Here we calculate it and get our optimal answer, which is 31.5, and this is the most optimal profit. So mainly we use way 3 when we are greedy about both profit and weight and get our optimal answer. Here is my algorithm for this knapsack problem. First step, we use a for loop to calculate profit by weight for each item. In the second step, we sort this value in decreasing order. And the third part, we use again a for loop from each item. Here, we use a condition when our capacity is greater than 0 and our object's weight is less or equal our capacity, then the current capacity is capacity minus object's weight and our profit is previous profit plus our object's profit. If this condition is not fulfilled, then we have to take fractional part, then our profit will be previous profit plus object's profit into our capacity divided by object's weight. Then we return our profit value P. Here is my code implementation. Here first of all we use a item value array ival, which is our classes objects array names, and in this array we keep our each and every object's weight and value. After that, we use a for loop. Here in this array, we keep our object's weight and value and our cost, and we use in our class part this cost is written in this part. After that, we sort our this array and we give a condition that we compare object 1 object 2 initially. After that, we again use a for loop for our current value and current weight calculation. Here is my condition, and if this condition is not fulfilled, then we will go to our else part and take our fractional part. And I gave my sample here, and my input and output sample is here, and we get the maximum value, and it is 31.5. Then this is our complexity analysis part. When we use first for loop I is equal to 1 to 10, as we use all of the objects, so our complexity will be big of n. Then we use sort algorithm in decreasing order in the second part. If we use the best sorting algorithm, which is quick sort, then our complexity will be big of n log n. And after that, we again use a for loop for all of items from I equal to 1 to 10. So here will be the complexity as same as first part, and this is big of n. So our complexity will, if we add 3 of them, then the large part is big of n log n. So this is the complexity of this algorithm. Application. A most important application of knapsack problem is while we take preparation for exam paper just before our exam week. And an interesting application for this knapsack problem is while we wanted to travel someplace and had a single bag to carry with limited capacity. Actually, in our exam, we want to use get more marks without using more words. So we can limit our study hours and we can get more marks if we use this fractional problem. Here is the references. We can take all of them in Java key points, tutorials point, Wikipedia, YouTube, and I also take help from my teacher's lecture. So thank you everybody for listening my presentation, and thank you Linta ma'am and Sonia ma'am.